All right, everyone, welcome back to another Stat3D5 video. So in this video, we are going to discuss some basics of object-oriented programming in R. We'll cover factors to motivate this concept, and then we'll get into the S3 object system, which is the simplest implementation of object-oriented programming in R. And it is the one that is most common, most widely used. There's others that exist, like S4, R6, but S3 is the one that's the most commonly used in R. And just as a preliminary, if you are coming over from Java or other programming languages that use object-oriented programming, this is going to seem much different. It's going to be a, what's the way to say it? It's going to be, it may seem weird or sloppy or scary, or, more positive way to describe it is flexible. So it's a very bare bone implementation that allows the users to do a lot with it, and, potentially can create some own some problems because of how much it allows. So it's very, very minimal system where minimal in this case means if you were to remove any piece of it, the whole thing would fall apart. But I like this quote that I read to describe it. It allows you, the user, to shoot yourself in the foot. But in practice, that's only going to happen if you're actually taking the gun and aiming it at your foot, and then pull the trigger in that way. So, for instance, I have used S3, the S3 system when I've created software packages, and despite at the time not knowing all the ins and outs of it, did not run into any problems. So I think that that's a fair quote. Okay, so before we get into S3, it's something that has been running the entire time. Right now, this is using the S3 system. You may say, well, that's really silly because all you did was just create some object and then run it. But really what's going on is, okay, so I have this vector of length 1, and I've just displayed it. Well, really what's going on under the hood is that there's a print statement specific to this object, and then that displayed the object. Now, to be technically correct on this, the print statement, when called, does not necessarily display the object. Rather, it displays some, in most cases, sincere attempt to visualize the object to a user, but that's not the object itself. And we'll get into that as we go. Okay, so that's silly, but let's try something else before we get full on into S3. Okay, so I'm gonna do this, borrow some code that I have to the side. Okay, so I'm going to suppose that there is 4 types of weather. These are the only 4 types of weather that can happen. Obviously, this is really silly, but just for to demonstrate the concept, let's suppose that there's these 4 types of, oh man, it would really help if I spelled things correctly. Weather types, and then what I'm going to do is I'm going to create a weather events for an entire year by sampling randomly with equal probability. So obviously this is a rather silly construction. Okay, so what do I notice when I print this vector? You can see that what I've done is I've just taken a character string, these separate characters, and I have them in a character vector. Okay, so if these are the only 4 outcomes, then in R, I could use stuff like this. And this may be problematic because it allows users to change. I only want 4 values, and those are the only 4 values. And so now in this way of describing, or this way of displaying, organizing, collecting data on the weather, it now gives users perhaps too much flexibility. Another thing is object size for the weather. So this character vector has 3,248 bytes, and you may say, well, that's not that big. But this isn't really a large data set, and there may be cases with large data sets where we want to be very concerned about the space that our objects are taking up. So in this case, maybe not that big of a deal. So now I'm gonna try something. Actually, let's just, before we move on, we'll go to some of our old friends, type of weather, and we get, character vector and whatnot. Okay, so I'm gonna try something slightly new. I'm gonna use the factor function, which converts this character vector into a factor. And look, it's a little bit different. So what are the differences? Well, I still have the words on the screen, but you can see here that I have levels now. Oh, wait, you know what? I want to actually start over. I don't want this ZZZ thing floating around. Okay, so now I'm back to 4 levels. Okay, so now let's just work with this. All right, so now if I try weather 365 equals ZZZ, it complains. And what does it say? It converted it to NA. It's not an allowable value by our factor variable. So there's some more rigidness with this. Okay, but now let's just go back, start it over. Weather, don't need this anymore. Okay, now we're back. All right, so we don't really know what's going on. It looks somewhat similar to the character vector, but there's these levels. So now it happens what's called the structure on this object. Okay, so now we're getting a little bit more information. We can see here it's a factor with 4 levels. It doesn't display all the levels. The print call to it did. But here we can see some integer codes for it. So if I were to do type of, it's integer. So that seems rather odd, of course. Can we manipulate this in any way? No. Okay. So what's going on essentially is that in the factor world, it's taking the level, or the characters, the character strings. There's 4 of them. These different types of weathers. It's assigning them a numeric code, and then it's in the form of an integer, and then storing that. And then so that will have a little bit of size reduction. So it's good for our size considerations. It's also good in data analysis. So we won't linger on this now, obviously, and we're not going to be building like regression models to do complicated tasks, but you may have something like a regression on weather. Maybe you want to know temperature, try to predict temperature based on some set number of variables where weather is going to be one of them. So here we have a qualitative variable, which would get a numeric coding inside of a model matrix. And then, so this integer coding is actually very, very, very useful when you actually do regression, because you're not going to have, if you remember even, some about statistics in the least squared estimator, that's a function of, essentially a model matrix, right? And your response vector. And you're not going to have cloudy as an element in that. You're going to have some numeric code representing cloudy. So that's what's going on under the hood here with factor. So it actually has a data analysis point to it for when you have qualitative variables in some sort of regression, for instance. Okay, that was sort of, hope that helps for maybe another class that you're taking, but we're not gonna use that point now. But I can create these factors manually from the integer coding itself. So now I'm going to try this. Whether I'm now sampling integers. Okay, so here's a new thing. Actually, should I go back to, wait. I went ahead of myself here. No, I didn't actually. Okay, so type of. Okay, anyways, sorry, I thought that this was already displayed. So here, I'm going to display a new concept, a class of an object. So here it's very, very simple. This just, if you have integer vectors, it has its own like implicit class, which would be integer. So like if I do type of, these things are, let's see, yeah, the same here. But now what I'm going to do is create, I want to get to a factor variable. And so I'm going to have to mess with the class. So here I have nothing. So how do I go from integer to factor? Okay, so what I can do is I can specify some of the attributes for this factor. So first I'm going to add levels as an attribute, and I'm going to give it the ones I have here. Okay. And then I'm going to change the class from integer to factor. Okay. All right, so now when I display weather, I get something similar. Let me just scroll up on my output here to this. See? Okay. All right, and if I call that structure, that shorthand for structure, then I get the same sort of output here, factor with 4 levels. And you can see the integer coding corresponding to each one of the names here. Okay, so I can also do this, let me try it again, using a command called, or a function called structure. So structure, we'll call it weather int. That's the thing that's, okay, so I have my integers and I'm going to specify everything internally inside this structure call. All right, and class equals factor. And we'll call this weather fac. Okay, so I have integers and now factor. Okay, and to drive this point home, let's combine all of this in a data frame where we display the numbers, the integers, which we built the factors from, and the corresponding factor codings. Okay, so you can see when I call this data frame, we have 4 corresponds to snowy, 2 to cloudy, 1 to clear, 3 to rainy. And you can see that that is consistently the case. So, right, so this factor variable, under the hood, it's actually an integer variable with this coding, but actually does have these labels, if you like. But in representing, this is not a character vector, it is an integer vector, right? If I go to type of weather fac, it is integer. Okay, so it's just a very special form of an integer vector, and even though it also has some similar characteristics to a character vector. Okay, so right, so if I have class whether fact, it's factor, class whether int is actually integer. So even though they're both considered integer vectors by type, by class, they're just two different things. One little weirdness here, okay, is dot integer. So recall our integer vector. True, right? Well, unfortunately, we get a little bit confusing when we have this integer vector. Okay, so this is something you can read the documentation on. It's a rather slightly, I guess, annoying inconsistency in R that you would have an integer vector by type, but when you call the is.integer function on it, then you get this this false here. And I think, long story short, basically this integer coding for this factor variable is not something that you want to be supplying into like another like mathematical like form. You don't want to take the square root of the integer codings. They mean something. And so R is not going to let you do that, and R's way of differentiating that integer vector, the integer vector and the factor, and just a plain vanilla integer vector that you can manipulate with math functions, is to do this type of thing. You can read more about it in the documentation if you're interested. Okay, so going back just a little bit, or maybe actually summarizing, whether int, we have an integer vector print statement, we print out the object, and whether fac, when we print it, it's a little bit different. So what is going on here? And this is what we've been sort of talking about under the hood, is the S3 system, is that we have this print method which is providing two different outputs to objects of different classes. So here, what happens if I do print.integer? Can I do that? Okay, well, okay, just to get a base case. Okay, that didn't work. Okay, well, anyways, I can see by calling methods, I can get a list. Sorry, I shouldn't say list in this way. I should be technically correct. I can return the different types of printing methods exist in R. So this won't be everything that exists in all of R, but this would be what exists, I think, corresponding to the functions that, or sorry, the R packages that I actually have locally. Okay, so one that's interesting here is print.default. So what happens when I do print.default, whether int? I'm pretty sure this is just going to return integers. And what happens when I just change it to that? Okay, so this is what I was actually trying to get to earlier when I was doing print.integer, but I was being a little bit floppy. Okay, so here we can see that this is just like the very, very, very basic form of printing. Now if I remove that, since whether fac is a factor, it's going to understand that whether fac is of class factor and apply the appropriate print statement, so that you print the index, or the levels at their indexes, and then information here about the fact that there are levels. And this is a factor variable. Okay, cool. All right, so let's try something. Let's continue down here and expand on this further by creating a generic class. So as I may be known to do, I'm gonna create some numbers first. And then what I'm going to do is take my object X. Okay, actually first, before we do that, let's go slow here. Class X is integer, right? We just saw this. It's of integer type. And here the implicit class for this is just integer. Okay, so we already knew that. Here's where things may get a little bit scary if you've seen object-oriented programming before in a different language context. I can just overwrite that and just give it a new name. We'll call this class stat35, different class. Is that funny? I don't know. Anyways, okay, so we've given X now a new class. So hey, it still prints, but now it prints this new attribute that we have for it. Okay, now where things get fun is I can take my print method and tell it to do something for objects of class stat35. I think it just gets funnier. Okay, so this is obviously dumb and silly. So now if I do print X, I get hello world. Okay, so the object itself is still an integer vector from the 1 to 100, but now the print method is displaying hello world. Can't get around it way. So again, so when you call just a basic object in X, it's under the hood is doing a print statement, and it's doing a print statement specific to the class of the object that you're working with. And somebody had to write those print statements. The reason why I say that is because working on software packages to do specific statistical tasks, you may have seen like a summary table in R. That's a print statement, right? And then it's a formatted table in a way that's if you've done good software design, is very familiar to the one that is given in by LM, like print.summary.lm type thing. So I've had to actually write that summary table before inside of a summary function and a print function corresponding to it. Okay, anyways, that's a long story short, but like under the hood, what this is doing is actually calling print every time you display it, but the object itself is still integer. Okay, so, and if I were to override the basic print, so print here, what I mean by override is that X is of class stat35. I've written a print function specific to stat35. So here the idea is generic function, which is print, dot class. So here it's just going to do, it's going to reference it's going to pull the object's class and then just do print for that specific class. But now with default, it's going to do a more basic representation. It's going to go back to the start here and display this bare bone. It's more appropriate print statement. I shouldn't say that print.default is always more appropriate. In this case, it is because I did something silly, but it's going to recognize that the object is of type integer and go from there. Okay, so one little thing here. I did all of this very specific to the object with the name X. If I change that object, then I'm back. I would have to create a new print statement or a new class for this particular subset of X. Okay, great. Continuing on slightly, mean X. Okay, so even though X is still printing here, still knows it's an integer vector. And if I call the help page for mean is also a generic function. So print was a generic function, mean's a generic function. So what I can do is I can create a mean function specific to objects of class stat385. Okay, I don't like that. Okay, so what I'm gonna do is do something like this, where I'm going to remove the smallest 5 elements of the vector, no, smallest 3 elements of the vector, and take the mean. You want to, I don't know what the context is that you would do this for, sorting the elements of X and then removing the lowest 3 and then taking the mean, but we're going to do it. Okay, so mean.stat385. So now mean X, it's 52, where you take the mean of this character vector, it's 50.5, so it's subtracted out the 3 smallest values. Or if you like, mean as dot integer X, get some function composition in there too, nice. Okay, so here, right, so what am I doing here? I have a basic object, integer vector. I changed its class, and then I wrote a print statement for objects of that class, and then I changed around the mean function, wrote a mean function for objects of that class, and then I can show how those things can be, the silly things I've done can be overwritten. Okay, and let's continue on. All right, so now I'll make a new generic function. So let's take my object X again. Okay, so let's be really careful here. So I now have taken the integer vector from 1 to 100, and now I've assigned it a new name X. So in my global environment, the object X should have actually changed. So here you can see that it's integer again. Just to check. Yep, we're back. Okay. So I'm gonna make a function that just shuffles the values around in X. Right now they're in order from 1 to 100. Okay, so I'm gonna make a generic function, like print or mean or something. Use method shuffle. Okay. Right now this shouldn't do anything because there's no methods assigned for specific objects. Yeah, it's going to complain. Yeah, see, you can see here in the error message, actually pretty descriptive. No applicable method for shuffle applied to object of class integer numeric. Okay, so one little thing is here. We talked about this very briefly, too briefly, but I always in shorthand brought it back and mixed it up, because there's really, when you're doing mathematical manipulations, adding things, squaring things, whatnot, there's not really much of a difference between an integer vector and a vector of type double. So I often refer to them as numeric. So here you can see here that technically shuffle, or the vector X, or the object that shuffle was being applied to, is an object of class integer or numeric. If you remember, to get really specific, the mode of both of those is both of integer and double is both numeric and things, and that allows for these mathematical object or operations to be supplied on either one of these two things interchangeably. Okay, well, I shouldn't say interchangeably. That's not technically correct, because if I had a double and an integer and then added them together, then I would have type coercion. Okay, so anyways, long story short is I have this generic function that I'm trying to create, and that's great, but I haven't actually written specific functions to apply to objects of specific classes. So what I can do is rectify that by writing specific functions that are applicable to objects of specific classes. So here we go. very simple. I'm just going to shuffle the indexes. That's the sample function at its default. So now when I apply, or when I use shuffle on my integer vector, it works. Awesome. Okay, I'm going to run into a problem if I were to do something like this. See it? What happens? So x plus 0.01, I'm going to get a length coercion. This is going to be turned into a vector of size 100. It's going to be added to this integer vector. This is now a vector of length 100. Double plus integer is double. So I have my shuffle function that I specifically wrote for integers. So not cool. I need to write a new function. Shuffle dot double. Okay, now shuffle should work fine. Great. Shuffle works for integer, shuffle works for doubles. Of course, I could have just, let me just get rid of everything and clear it and just bypass this and just write shuffle dot numeric. Okay. And we will comment all this out. Okay. Didn't work. Integer. Okay, so now shuffle.numeric. So I have my shuffle method. Now I'm writing a specific function that is applicable for objects of class type numeric. And it works. Okay, great. Now I can continue on. I can do shuffle.character. But perhaps what I want to do is just write shuffle dot, actually, default. Okay. Let me pull these down. Let me get rid of this. Okay, let's clear everything. All right. Okay, start over. Integer vector, shuffle method. Shuffle doesn't work because I haven't supplied the classes that it works for. And now shuffle.default, shuffle x. Now we'll add a new one. Shuffle. Okay, so anytime you want to try something on a character vector, you can just use letters. Should work. Okay, so I made a default shuffle method to apply to be appropriate to objects of all kinds of different classes. Okay, great. So now let's say what we want to do is, okay, I have my shuffle function, it's going to work for everything. But let's say I want to do something very, very specific for just objects of class function. So let's keep, or sorry, yeah, class factor. Let's see, class function, silly. All right. So bring this back. So now I have, oops, what did I do? Oh, that's right, I can't spell. Okay. All right, so I have my factor vector. Remember, an integer vector of class factor. Okay, so let's just see, since I created a default thing, it should just shuffle the values around. Okay, it does. Great. But now let's say I want to make my own. Let's say I want to actually shuffle the values around like we've been doing, but also shuffle the levels around. So I'm going to make a new argument. Okay. So let's see here. X equals sample X. If levels. Okay. levels x. So I'm basically, okay, actually, let me, before I do this, yeah, I kind of want to see what's going on here. Okay, so so the argument is gonna be given x, but right now the thing I'm working on is weather. So let's just try this levels command real quick. So this just isolates the levels out. So if I do sample levels, oops, yeah, not that. Sample levels, more function composition, great. So you can see it's mixing them up. It's doing this randomly. Okay, great. So the idea here is that my shuffling is going to shuffle the values and the levels. Okay, that looks like that works. That's probably not proper testing, but pretty good. Okay, so now, and then it's going to return the object at the end. Okay, great. So shuffle factor. So first of all, okay, so now I have it. Wait. That's not going to do it. I need to actually, going a little bit too fast. Function. There we go. Okay, now I have a shuffle factor function. So now this is going to do something slightly different. Let me scroll up. Here the levels were in alphabetical order. Now, wait a minute. Is it still? Oh, levels equals false. You know what? I think, oh, I see. Wow. Okay, to tie it all together, I need dots, don't I? Okay, so for my generic function that I'm creating, there's a particular class where I want to supply additional arguments. Now, generally speaking, I wouldn't need to specify an argument to call this function. But in these cases, I will actually need to supply additional arguments. This is the perfect tailor-made example for why dots is something that is useful. So great. Okay, so shuffle.factor. Now it works. Okay, so you can see here that it's changing the levels around. It's cool. Yeah, I think it's cool. Okay, cool. I could have also, instead of calling shuffle, I could call, shuffle.factor. That wouldn't even have a problem with the dots, but since I called shuffle directly, that has a problem. And that's why I needed dots up here. Okay, cool. So we did factors, showing how they're integer vectors, but not really, right? You can't actually add them with other, objects. The integers represent a factor level coding corresponding to those levels. And when you display the factor, of course, even though it displays the levels itself that you can see here, they aren't actually character values. Okay, then we did creating our own classes for objects and then messed with generic functions to create functions specific to objects of that created class that we did. We'll demonstrate with some silly examples. And then we actually created generic functions from scratch, doing relatively silly stuff, but then we can show how general we want to make our generic function. We started with the integer, then we went to integer and double, and then we decided, well, I don't want to do that. Let's just do numeric and handle both of those cases, and then realize I don't want to do that either. I want to do a default function to apply to all types of objects. And then after that, we want to walk that back a little bit and do something very specific for just factors. I should actually, now that I added this shuffle.factor, I knew that there's something else I want to do. I want to go back. Let me just rerun everything. Now I want to go back and make sure that this still works. Shuffle X, yep. Just so we're being absolutely transparent, I'm going to add these here. Okay, and run it. So you can see Shuffle works for factor, and it's mixing up the levels, and then it also works for integer, double, character. And here I don't need to specify anything in the dots because the specific function for objects, these classes, don't require additional arguments. Okay, that's some basics into S3 methods, classes, factors. Factors will come up again. S3, you may not be, needing it to actually create your own classes or generic functions or whatnot, but it's good to know what's going on under the hood. And if you do create software in R eventually, you will have to engage a little bit probably with this S3 object-oriented programming system in R. All right, that's it. You made it to the end of the video. Yeah, thank you for your attention. All right, take care. Bye.